This video is about levers. The first lever, there are three classes of levers. The first class is class 1. A class 1 lever has the fulcrum placed between the effort and load. The movement of the load is in the opposite direction of the movement of the effort. The length of the effort arm can be greater than, equal to, or less than the length of the load arm in the class 1 lever. Examples are a shoehorn and scissors. The parts of a lever are a load, fulcrum, and effort force. The second lever is class 2. A class 2 lever has the load in between the effort and the fulcrum. In this type of lever, the movement of the load is in the same direction as that in the effort. The length of the effort arm goes all the way to the fulcrum and is always greater than the length of the load arm in a class 2 lever. The example is a wheelbarrow. The last class is class 3. A class 3 lever has the effort arm in between the load and the fulcrum. Both the effort and the load are in the same direction. Note that the length of the load arm goes all the way to the fulcrum and is always greater than the length of the effort arm in a class 3 lever. An example is a tweezers. Now I'm going to talk about mechanical advantage. The mechanical advantage is the length of the effort arm divided by the length of the resistant arm. So say we have a teeter-totter. We're going to be using tan with the distance of the force, which is dF. The length from the force being pushed down to the fulcrum is 2 meters. So we'll have tan theta equals the distance of the force over 2. Now on this side, from the fulcrum to the what we're going to call dW is the distance moved weight up. So this will be so the force will be pushed down here and it will move up to here. So this red box will be where our dW will end. So for this side we'll have tan theta equals the distance moved weight over 1 because it is 1 meter from the weight to the fulcrum. So with this we go, since these two will equal each other, it's dF equals 2 times dW. So over here we do the force times the distance of the force equals 20 because this weighs 20 newtons. So then we go force times 2 dW equals 20 dW, and then we divide by 20. We divide by 2 dW on both sides to get that the force equals 10 newtons. So this will end up being 10 newtons here. And then for mechanical advantage, it's the outward force divided by the inward force. So that will end up being 2.